Okay, I understand that my introduction is very brief. So we have done almost 25% of my introduction. So basically it's not finished, but almost finished. So I would like to tell you about which resources may be useful to you. So, because I understand that so let me share screen. Oops. So I will share browser. So what may be useful. So if you just type R for data science. So this is a good book by Hadley Wickham, R for data science. So that's one good source. I will copy in Telegram chat also because chat in Zoom will die. What else you may find are econometrics. You may find principles of econometrics with R. You can find introduction to econometrics with R. And I think there's 2 books for econometrics with R. Oh, that is one. And there's another one. About time series, I think the best source is Fable R package. I think the official I think for time series introduction, that one is good. FPP, forecasting principles and practice. And basically for plots, plot, I think too, org. Yeah, that one for plots. That one for plots. I think basically that these are the sources for general data manipulation, like data science, 2 books on econometrics with R, 1 book on time series, and the last one for plotting, because plots is the main way we use to convey the information. Okay, let's move on. Let's move back a little bit in RStudio. Okay. Share screen. Okay, let's change the order of exposition. Multiple regression. Maybe it's better nowadays to start with robust regression first. I don't know, but we used to standard order. So first assumptions about homoscedasticity, then estimators of standard errors on the assumption of homoscedasticity. But maybe it's best to start modern courses with heteroscedastic setup. I don't know yet, but maybe it's the right way. Maybe we're in a 21st century after COVID time, and then we need to move forward. So let's attach a package, a library st. Oh, it's not installed. St-matter. Okay, let me, because I have renewed RStudio up to the version 4, and some packages are not installed. St-matter. I will install St-matter package. Okay, I will drink a tea. Because the installation is done once, so it's okay. That it takes a little bit of time. When you reinstall a version of RStudio, there was some major changes between third and fourth version. So while it's installing, I can continue typing. That will slow down, but not too much. No, too much. Well, it's better to wait a little bit. What can I tell you while we wait for installation? How to search for help. Yeah, let's discuss how to find help. Basically, I will stop for the moment. How to find the help. I will share screen with my browser. Share. Okay, obviously you can Google some how to, I don't know, how to make a regression in R. Yeah. Maybe you should know about some resources that are more specialized in R, like you should know about RDRR.io. So it's also a search engine, but it's specialized in R documentation. So if you search here regression, maybe it's more relevant. What else? So you may find a package with some name. So if you don't remember, so it's RDRR.io. It's a special resource to search. It's a special engine to search something related with R. What else? You should also know about stats, StackExchange.com. So basically, it's RDRR.io. So basically, it's a statistics related forum, and basically there are questions about statistics, about general linear models, so I don't know, extremely wide logistic regression results and so on. But a lot of users on this cross-validated Stack Exchange, they know R, and if you see tags, there are a lot of questions that are related to R, and if you're unsure how to estimate that or that model in R, so it's okay to ask there. Set a special tag R to your question. And then there is also R bloggers. That's a very active community and if you are searching, I don't know, for ideas for your coursework or just some top R-related news or statistics-related news, so maybe it's a good resource to take some inspiration or just so that's a hot blog about R and R related things. And there is also R Studio. That's not only the place to download R Studio, but there are also good there are a lot of open webinars, videos, cheat sheets, and so on. So features, they are free, and maybe you have so this is they create high quality content. So if you'd like to search for help, that's a good source about our studio and everything else. So do not forget about our studio resources like this. Yeah, so that's also a good source. That one, stats, Stack Exchange.com, and our bloggers. Hope maybe you will find something that is top-notch, very sharp, new things that are maybe useful and will advance your work. Okay, I will go back to R. Maybe, yeah, everything is installed while I have discussed some popular web sources. So I will stop sharing Firefox and share screen RStudio. Okay, I have installed Estimator. Now I can use it. And now I can use heteroscedasticity robust regression from the start. So let's start heteroscedasticity robust regression. So model equals to model A equals to LM robust data I will take from diamonds data set, and for example I will model the price of diamond using the weight of a diamond plus X plus Y plus Z. So that means, sorry, formula equals to. So basically that is the equation price I equals to beta 1 plus beta 2 times xi plus beta 3 times yi plus beta 4 times zi plus ui. So that's the model estimated. So basically this tilde symbol separates left-hand side from right-hand side, dependent variable from regressors or dependent variable from predictors. Normally, the most hard thing to estimate regression in R is to find the tilde on the keyboard. Normally, it's located in the upper left corner of your keyboard near the letter Yo, but it's somewhere in the upper left corner. The constant is added automatically. So if you like to omit this, so the model is estimated. We can look at the results of estimation, summary model A. So basically that's a standard table you use to if you have ever estimated a regression in a software. So it's the first column is the estimate of a coefficient. The second column is a standard error robust to heteroscedasticity. HC2 correction is used. Then is t-value to test hypothesis that the coefficient is 0, and a p-value interval from left to right, And degree of freedom is not interesting. I don't know why they include here degree of freedom. It's junk. We don't need it. I don't know why they include degrees of freedom here. The same number for each row. I don't know, but okay. So just a question to check whether you understand. Who can test the null hypothesis, the H node, that beta z is equal to 0 against H alternative that beta z is not equal to 0 at, let's say, 1% significance level. Who can using these results regression, who can test this hypothesis, whether I should reject it or do not reject it?
We need the t-value column, and then we need to extract this certain value of beta.
Just almost without any calculations. You have p-value. This is p-value. So everything is on the screen. So it just.
We can say that caret is significant and other variables are not.
We look at the beta z. So we, in my equation, I look at this. Oh, sorry, I forgot about beta caret in my, sorry. It's beta c times caret. So I forgot, I have 4 explanatory variables and not 3, sorry. I have beta caret, beta x, beta y, beta z. Well, let's name it like that, sorry. It was a constant, beta before caret, beta before x, beta before y, beta before z. I have 4 explanatory variables in my regression. Okay?
You can say that the null hypothesis could not be rejected.
So I look at the last line, because last line corresponds to the coefficient before the regressor z. So I see that estimator hat beta z is equal to coef. So I may extract everything from my object. Don't forget that model A is list, yeah, coef. So if I look coef, model A, these are coefficients. Okay, and I need the last one. That. Okay, this is beta hat. Okay, this is the coefficient, and if I look, I don't need to make any calculation. So if I look at these p-value, in my case, p-value is 0.12282 and something else, yeah. And I see that my p-value, this e minus 1 means multiplied by 10 to the power minus 1. And in my case, I see that p-value is greater than significance level. Yeah, p-value is greater than significance level, and that means H node is rejected or not rejected if p-value is too high. You are master students. How we test
not rejected.
Is
not rejected.
Yeah, you are right. You are a good master student. Okay, yeah, H node is not rejected, and the beta hat z is not significant. So from statistical viewpoint, it is like 0. Yeah, we have no evidence that is too much different from 0. Not significantly different. It's different from 0. Yeah, we may see that it's not 0. Yeah, the coefficient, but from statistical viewpoint, it's more or less like 0. Okay. So now we may compare it with another model. So we may remove X, Y, Z. So let's compare two models. Model B is, I will create a little bit simpler model. I will remove some coefficients.
Excuse me, but I have a question.
Yeah.
How do we extract the p-value from this summary of model A?
Yeah,
like without writing it by hand.
I understand your question. So basically, let's put a summary about. So basically, what is the meaning of every comment? When model A is calculated, only minimal information about model is calculated. So coefficients are estimated, but not all statistics are calculated. So automatically, as far as I remember, betas are estimated, but R squared is not calculated automatically. And summary model calculates a lot more information. So let's put the result in summary A. Let's put the result. So model A, what does it contain? We may, for example, look, we have in our global environment, we have, where is model? Where is model? Yeah, we have model A, and it says it's a list of 28 objects. Yeah. So we may click at it and look inside. So what do we have? We have a very big list. Yeah, we have a very big list. Model A, it has coefficients, standard errors. It has p-values are calculated not in summary, but in p-value. Yeah. R squared is already calculated. I'm wrong. R squared is calculated. And summary. What does summary has? Summary has, maybe summary has something more. I don't know. Okay. So everything I need is here. In model A, it's called p-value. Okay. So if I say model A, how to extract something from a list, I need double brackets. That's important to work with a list. Double brackets. So how it was called? It is called p point value. Okay. P point value. It's a vector. And I need a force component of a vector. It's a one-dimensional object. So I need if I need Z, it's coefficient number 5. Here it is.
And in the end, we got a format of a solver table, or is this just a number?
It's just a number.
Okay, thanks.
You will look at the structure of p-value, and it would say that's a named numeric. It's a numeric with some additional attribute, but it's like numeric. So it's like numeric. All you can multiply and so on. Even you can click. You don't need to understand the thing. You can click. I click model A. I expand p-values. I need a p-value for Z, and I click this small table with an arrow. I click it up, and it will. It's alternative syntax, but it will also work. I can just up and look at the p-value. Let it be Z p-value. Yeah, Z p-value. Okay. Any questions?
Yeah, sure, that's clear. Thanks.
So we have extracted anything from model estimation. Now let's estimate two models and compare model B with model A using, I don't know, some tests that are appropriate. We have estimated model B, and we can compare. Model B is a restricted model. In our case, model B is a restricted, simple model. Model A is unrestricted model. And I can compare using, I think, LR test. LM tests. No, very like, let's install LM tests. Maybe it's LM test without S. Okay, and now I think this is for many tests for econometrics, cross-sectional econometrics. What else? So, and I may write here something like LR test, model B, model A. Oh, that doesn't work. Okay, and if I do something like F test, ANOVA. Whoa, that's bad. And if I do something like F test. Just a moment. I saw that it's okay. Wald test. Okay, yeah, let's use Wald test. But it's strange. It surprises me. I thought that it has LR test function can be applied to them. Okay, that's strange. But okay, let's do Wald test. It's like F test, but it uses chi-square distribution. And our conclusion, which model is better, which is H naught, which is H alternative in our case, and conclusion. Which model, model A or model B is better? When we test restricted model again.
Don't we need the R squared restricted minus R squared unrestricted divided by?
No. The formula is a little bit more complex because you say formula for homoscedastic case. So that's basically, I don't discuss a formula. I'm about conclusion.
I see that the value is less than his key. Yes, am I right?
So my first question, what is H naught? What is the null hypothesis when we compare two models, restricted and unrestricted? What is a null hypothesis?
The coefficients on X, Y, and Z are equal to 0.
Yeah, the H naught, the null hypothesis is the restricted model. H naught is both models are true. So restricted is true, unrestricted is true, because restricted is a particular case of unrestricted. So if a smaller model is true, a bigger is also okay. Okay, H alternative is that only unrestricted model is true, and so restricted is wrong. Okay, so we have two hypotheses. We do not test whether, when I write assumptions like this, it's clear that we believe without any doubts in unrestricted model. When you test restricted versus unrestricted model, you believe in unrestricted model. You don't have doubts in the unrestricted one. You just check whether the simpler model is true, but you believe without doubts in a complex model. Okay, in our case, p-value, here it is, p-value. P-value is very, 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 very small. Yeah, it's p-value. Yeah, it's smaller than 2 times 10 to the power minus 16. So p-value is very small. P-value is very small, then the null hypothesis is
rejected.
Yeah, p-value is smaller than 2 by 2 times 10 to the power minus 16. So what does it mean? Smaller than 2 multiplied by 10 to the power minus 16. It's a scientific mode notation. Okay, and you're right that H naught, the null hypothesis, is rejected. That is our conclusion. Okay, and we prefer unrestricted model because both models are true. This hypothesis is rejected. Okay. Okay. Any questions?
No questions.
Okay, what else can we do with linear regression? We can make predictions. Predictions. So let's imagine we have a new data table. What is included in our model? What is included in our model? Caret x, y, z. Okay, so caret will be equal to, I don't know, 5 carats, 10 carats. Oh no, 10 carats is very, 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 very big diamond. I don't have money for 10 carats. 10 carats. Okay, that will be the weight of a diamond. X measurement, I don't know, 1 and 2, 2 and 1. Y measurement in millimeters will be 3 and 2. And Z measurements will be, let's say, 4 and 2. Okay, this is new data. I think I have everything I need. Yeah. Let me check. Caret x, y, z intercept. It's automatically added, so I don't need to create 1, 1, 1, 1, 1, 1, 1, 1 column. So I can predictions. Predict. Model A, and I think I need new data like new data, and I can see predictions. Okay, or I may add I may calculate interval so let me look at the syntax. How should I specify interval predict? In interval I should write predict lm, type of interval predictions. Okay, interval equal to prediction. Okay, and I have predictions. Yeah, I have not only point forecast, but also upper and lower confidence interval forecasts. This is point forecast, and that is interval forecast. Okay, what do we have else? What else we can do with the regression?
And what is the default confidence interval?
95% you can read. So you can you see there is a level. So in documentation you have default is 95%. You can change it. You can say level equal to 0.8 or 0.9. Or something. 99 is also reasonable. So just do not forget that you can have
okay. How do we get the residuals from the model?
How do we get residuals? There are two ways. One is already known to you. You go to model and you see where are the residuals. Where are the residuals? There are fitted values. Yeah. What else? At least I have fitted values. Yeah, I can always subtract y from. Let's look. Maybe they're built in summary. I know the command, but I think it's summary A. So anyway, I know the answer is residue. So they are not residuals. Residuals. That's strange. Okay. Let's say model A fitted. Fitted values. And what was my? It was diamonds. What was the dependent variable? I think it was price. Yeah. Yeah, these are residuals. Some authors care about extracting residuals. So when you estimate a standard built-in LM command, you will have resid options. So sometimes for some models resid will work, but not for robust LM. It's pity. We should make. I think I may have. So if you are proficient enough, and you go to LM or robust, it's package st matter r package. And you go here, and if you submit changes to that package, yeah, if you provide pull requests, that will work with residuals. So I think I will grade you extra points because it's a good idea to be able to extract residuals automatically. Maybe we have tidy. Yeah, maybe we have a maybe we have tidy results. Okay, so if you'd like to commit to make software better, I will give you additional points. if you'd like to make software better.
I got it. Thank you.
Yeah,
maybe,
yeah.
Maybe it's a little bit late. We should have done it earlier, but did you examine how to have the descriptive statistics of our variables? Some summary statistics?
Yeah, obviously. We can, what are the possible ways to do it? To do it fast, something like library. Oh, I forgot about library. There is a built-in command, but I don't like it. I forgot the name of the package. Just a moment. Library.
You don't like it, and that's why you probably forgot.
No. I don't like built-in commands. So there is something like there is built-in is just a moment. Built-in is just, I think, str. No, not str, but summary diamonds. I don't like it. Yeah, this is built-in. I don't like it. So
Why?
this is built-in, but it's ugly. It's ugly. And I forgot the name. Why it's ugly? Because it's everything you have minimum and median, and so on. But the point of view, you cannot work with this output. It's not a standard data frame. And the package I like, library. Just a moment. R open science. Descriptive statistics. I forgot the name.
Okay, I think we can Google it.
No, because you may Google, but because when you Google, you obtain some ugly code. This is ugly style. Don't do it like this. So just a moment. I will find what was the package. I remember that it was Air Open Science. Just a moment. Oh, just relax for 1 or 2 minutes. I will recall.
You can remember it later and tell us in the next lecture.
Maybe, but that's a good moment to find it beautiful. Maybe I have. Yeah, it's called Skimmer. Yeah, library Skimmer. Okay. Yeah, I recall it. Library Skimmer. Yeah, that's good. Okay, and now I have Skim. Yeah, Skim diamonds, and it's much better. Library Skimmer. Yeah, that's much better. Why it's better? Because I have a standard table. The output is a standard table. I have small histograms even in graphics. I can work further with these tables. I can also group by. So why it's better? Okay, that's much better. I can group and I can work with group statistics. So for example, I'd like to calculate summary statistics group by group for ideal diamonds, for fair cut diamonds, for perfect diamonds, and so on. So I just say group by diamonds. I group them according to, let's say, color variable, and then remember the good syntax. You may skim. Yeah, you may group by, and then you skim. And then, yes, you will have a long, you have a very long variable. So for the variable caret, when the color is D, the mean is this one. The variable caret, when the color for another group of diamonds, for group with E color, they have the same mean. But when the color is F, the mean is different. Okay.
Earlier, you showed us how to export databases into different formats. Can we export this result of summary statistics?
Because it's a table.
Okay.
So that was my point. So we can say results, something like, and we can, I think, glimpse results. So we have a honest data frame. We have 63 observations. We have 16 columns. So that's the main reason. That's a honest data frame. It's a two-dimensional object. You can, I don't know, export res and summary XLS X or CSV. It will work because it's a standard table. And that will not work with built-in comment because the result is not an ordinary data frame.
Got it, thanks.
So this scheme has two advantages. It is standard table, so it's, and the second advantage, it works well with group by comment. So these two makes it's much better. I forgot the name. It's with, I remember something with milk. So when you skimmed milk, it's the top when the skimmed milk, like slivki. Okay, so it's, I remember that something, but sometimes I forgot the name. And it's difficult to find descriptive statistics. And when you Google descriptive statistics, you can find many ugly examples that works, but with a bad code style. And skim is a good good idea. Okay, so let's create here summary statistics. Okay, now we have regression, some prediction. Okay, now we have 5 minutes. Let's do some plots. Plots is a very big topic. Basically, there are a lot of good rules for plot design, but my main idea that a good plot is so two basic principles, just two principles. First principle is just the plot is self-explanatory, a good plot. So sometimes you do plots for yourself. So you have 5 seconds, you just need to look at the data. Okay, you remember the meaning of the variables, so you just don't write the names of the variables. But when you write a good, you publish a good plot, then it should be self-explanatory. The reader should not, oh, you have X. What is X? Ah, X is measured in dollars per capita and so on. So it's self-explanatory. and it has no junk. It has no junk. So if you use color on your plot, color should mean something. You just not color. The first column has red color, the second column of the histogram has blue color. That's nonsense, because you do not convey information with color. So every element should contain information. So you avoid three-dimensional effects as much as possible. So you avoid, you remove, I don't know, 3D, unused color, etc. So basically, that's all. And maybe it's not a principle, but a good plot takes a lot of time, because a good plot can replace one page of a text. So a good plot takes time more or less equivalent to one page of a text. It's okay. If you are not doing just a fast plot for yourself. So it takes, a good plot is like 1 or 2 pages of text. It takes time. So let me just make a fast plot, qplot. I take data from cars. X is speed of a car, Y is a stopping distance. So that is fast plot for myself. Yeah. And if I need to make a better plot, as you said, we may save a plot in a list. Yeah. So base. So it's base plot. Yeah. And I may modify it. So let's X label so speed of a car in miles per hour. I don't remember labels. Maybe it's like this. Maybe a label. I don't remember. Maybe. Okay, let's xlab. Yeah, okay, xlab. I'm modifying my plot further. Ylab stopping distance in feeds, and I might add title. Yeah, like stopping distance versus speed of cars in 1960s, in 1920s. Title, I don't remember plot. So it's not title, main, maybe main, because there are title, subtitle, so on. There are many. It's not title. I don't remember. Okay, so let's omit the title yet. Okay, let's move it here. We will find it together. So for the moment, our plot has no title. We go to ggplot.org, tidyverse.org. I will share my Firefox. Here it is. Here it is. Okay, we go to ggplot tidyverse.org because it's okay when you don't remember all the commands by heart. So let's first look at the cheat sheet. Yeah. What do we have? Coordinate system F geom call FO 3 variables geom bar stats coordinate labels. We have labs. Yeah, labs and title inside. Okay. So we go back to RStudio. Okay, labs X, Y, and title. Yeah. Speed of a car versus stopping distance in 1920s. Okay. So we may adjust further because we have, I don't know, we may adjust font to match the font of your work and so on. There are many subtleties that the font should be the same as in your main work and so on. But basically, this is a base plot, this is fast, and that with all the adjustments, it takes time. That's okay. When you prepare a high quality plot, be ready to invest time in subtleties. It's okay. So a good resource to find all the necessary. So I think the minimal, we may even start it from RStudio. We go to cheat sheets and we have data viz cheat sheets. So that's the first idea, to go to the cheat sheet. And then there are many more examples on this website. I have provided the link. So if you'd like to look at some examples, but basically be ready that when you do something fast, so that is fast. I remember by heart fast plots. But if you do something that is more or less ready to publication, then you need to invest time. Okay, so basically that's all for today. I will send you the script in Telegram in here. I will provide you so your home assignment is to register on DataCamp GitHub, and I will send you which course you need to pass before exam on the DataCamp, and I will provide you a full access for DataCamp for some months. Basically, that's all. Thank you for coming, and
here's a question.
Yeah.
Our classes be uploaded to the ICF system.
Yeah, I will upload, but I will do. Yes, I will upload to the information system, but I will upload fast on Telegram because it takes time to upload there, and there are visitors of the
PhD
cheat sheet plots. Simeon, you can just I will send the link in Telegram, all the links, but you go to help cheat sheets and all the cheat sheets are there. So that's an answer for questions. Could you send me the links for cheat sheet? So it's here to help cheat sheets, and yes, that's the same cheat sheet basically, but the site contains more information with examples, and cheat sheet has this is just cheat sheet, and that site is dedicated for a lot of that. So you can find a lot of examples of plot, and the cheat sheet is small. You can just print it and put it before you. That's the difference.
What is the agenda for the next class?
What is the agenda for the next class? I think I'm not sure yet. Either I understand that I have three classes left. Either we will start with time series, either we will do a little bit more plots because we have just started. Either I will explain you how to compare models in the Caret package, like for so some machine learning algorithm that you probably know how to estimate them. So Caret is like sklearn for R, and you should be familiar with that. So I'm not sure so I'm preparing for a class, but I'd like to improvise, and that's not I have everything that is written and I cannot go step to the left, step to the right. So I don't know, maybe either I will start with Caret, that is a sklearn analog in R. Either I will start with ARIMA and ETA in working with time series, as we continue a little bit with plots. So basically I understand that I have 3 weeks to do, but the order is not specified. If you need, I will put the agenda, let's say, the night before. So if you are thinking whether you should, but anyway, I will, the Zoom will, I will publish video recordings. So if you'd like to go to the cinema or just to walk just skating, that's okay. You may see later at your favorite speed. So I don't fix attendance at all. I think it's a crazy idea to fix attendance.
You will publish everything at the Telegram channel, right?
I will publish links in the Telegram channel. Obviously, videos I will upload to YouTube. So I need to download them from Zoom. I need to upload them on YouTube. So it takes time. But yes, I will publish all the links. Yes. So it's not a secret. So that's why I like to avoid the ICF information system, because if you publish that, it's available only for those who study there, and there are some external guests, and I like that. I like that when everything is available to everyone, because the education has enormous external effect if you publish it. But I will provide it from. Okay, so see you next time.
Yeah.
Yes.
Thanks. Thank you.
Thank you.
Thanks, bye.
Oh, so if you have any questions, any request, I don't promise that I will fulfill all your wishes. I'm not like Ded Moroz. But if you have some wishes, I would like to know, I don't know how to estimate logistic regression in R. So if I see, oh, there is a request and this request can be done in 5 minutes, so that's okay. So if you have some requests, don't be shy, just say it in Telegram. And if I see that your request is consistent with our agenda, or it's inconsistent with our agenda, but it takes 2 minutes to explain, so don't be shy. I will try to help you, but sometimes I may say, no, that is too far from our agenda, sorry, but Google it yourself. But maybe you will be lucky and I will just explain you how to tell it. So don't be shy, just write in Telegram your requests. Okay?
Okay.
Okay, see you next time. Bye-bye. Have a nice evening.
Thank you.
Bye.
Thank you.